Hey, Mr. Riley here, and moving on with our introductory things here to the language of algebra, shifting back after some positive and negative number discussion back into the first chapter and the discussion of ordered pairs and relations and graphing, a very important foundation for the rest of your math career. So we are on page 31 in the book. You can follow along there, right? So graphing, something that you've done before. Okay, so we use a coordinate system or coordinate plane to locate positions in space, right, on a piece of paper. Okay, it's formed by the intersection of two number lines that meet at a right angle, and their 0 points are where the two lines meet. Now, this particular graph is all positive numbers because we're in chapter 1. We will move on quickly here in the next lesson to positive and negative numbers on a coordinate plane, which I think you've already seen. Okay, so the coordinate plane has an x-axis that goes across, a y-axis up and down. 0, 0, the place where the coordinates are 0 in both directions is called the origin. And any point on this graph can be determined by using its coordinates, which are listed in an ordered pair. It's called an ordered pair because it goes x and y in order every time with a comma in between. The x coordinate is the first number, in this case of 4. The y coordinate is the second number, in this case of 5. And 4, 5, you would plot that point right here on this graph. Okay, all review. So this is a very quick, should be simple lesson here. Okay, to graph an ordered pair, the first number you go right or left. And this is all positive in this lesson, so you go to the right that many units. The second number, you start at the bottom, right, and then you go up to the second coordinate. 5, 3 is right here. The first coordinate of this next example, 0, and so you don't go left and right at all. And then you go up 4 for the y coordinate. So point K is at 0, 4. Make sure to label these when you're told to graph and label. You don't have to label the coordinates. You do not have to put the numbers in there when you label these, but you do have to write the letter. Okay, so the numbers are not required. You can tell what the numbers are typically by just looking. Now, sometimes if it was in between or difficult numbers, then you would put the numbers in there. But that is not required for these types of problems here that you're going to do on page 32, like this one. Graph these points. Okay, so how are you doing this in your book? Please don't write in your book. You could just, kind of eyeball it, or you could print these pages out, right? They'll be available to you. You could print them out to do the problems following along with the video. All right, so point Q, 2, 3. And notice that there's no numbers on this. And so that means that if there are no numbers, then that means that each space is worth 1 unit. It tells you here in this little sticky off to the side, right? If there are no numbers on the grid, then each line is 1 unit. So there's point Q at 2, 3. Point R at 5, 0. So 5 to the right and 0 puts it right there. Throw in a point R. Okay. Point C. I'm sorry, point S, number 1C. 3, 1.5. All right, well, 3 is going to be easy, 1, 2, 3, and 1.5. So I go to 1, and then I go halfway between 1 and 2. Puts it right there. Okay, halfway between 1 and 2 would be 1 and 1/2. Right? If it was 3/4, you go 3/4 of the way. If it's 0.4, you go 4/10 of the way. Okay, so hopefully your fraction decimal understandings are good for you to be able to do those, because that's something you need to be able to do, especially in an accelerated class. And lastly, point T, 6.5, 1/2, and 5.5. So from there, I go straight up 1, 2, 3, 4, 5.5. And so that one's going to be right in the middle, right there. That is your point T. Okay? Graphing given the ordered pair. Okay, which ordered pair? Write the ordered pair from the point that's given this. So they give you the letter here, and then you need to identify the coordinates. Okay, so you see where the point A you see where it is. So it's 2 units to the right. That's an x coordinate of 2. And 1, 2, 3, 4, 5, 6 units up. So the coordinates of point A, 2, 6. Whoops, 2, 6, right? The coordinate of point B, well, the x coordinate is 1, 2, 3. And it's on the y-axis. It doesn't move up or down at all. That makes it 3, 0. 3, 0. Okay. So there's 2 other points on here. What are the coordinates of these points? Point C, 0, 2, and point D, 6, 3. We'll do more of these with positive and negative numbers, much more interesting. So these are quickies. All right, now moving on to something new, probably new, okay? So a relation, any set of ordered pairs, any set of 2 numbers that go together is called a relation, okay? You can show a relation in a set of ordered pairs. You can show it in a table of values like this, right? You can show a relation in a graph because every dot on the graph has an x and a y coordinate that go together, okay? So these are the 3 ways. These are 3 ways that you can show a relation, all right? Now, every relation has a set of input or x coordinates. That set of x coordinates is called the domain, okay? The domain are the inputs of a relation, okay? The y value, the output values, is called the range. This is not to be confused with other math words where we have used range, okay? Just an aside here because it's important. What is the range that you have used previously in your discussion of measures of central tendency? Mean, median, mode, and range is where that one comes up. And in that application, range is the difference between the smallest and largest numbers in a set of numbers, okay? Totally different use of the word range. Both mathematics uses too, not like non-mathematics uses of the word range, like a big field where a bunch of wild animals roam, like buffalo, right? Or another word for your stove is also a range. People don't use that word very much anymore, but it's also another word for oven or stove. Okay, anyway, range for us, the set of output numbers, okay? Now, when you write domain and range, it's written as a set of numbers, so we write it in set notation, which means we use these braces, okay? We put the numbers in braces with commas in between them. And you don't have to write out the word domain and range, but you do have to put a D and an R so I know that you know which set is which, okay? You can't just write the numbers. And one other thing to point out is, it doesn't happen in this case, but if there is a number that is repeated, like you have an X value that happens twice in your table or a Y value that happens twice in your table, you only write it once in the domain and the range. It's the set of values. It's not just listing all of the numbers, okay? And some places will just put them the way they show up, like the range, like the domain here is 2, 3, 4, but then the range is 3, 5, 1, the way the book shows it here. It's a little more stylish to write the range in numerical order from least to greatest. Okay, so I rewrote this same problem, the range as 1, 3, 5, going in order from least to greatest. It's not really a requirement. In fact, in my regular math classes, I don't mind if they write it this way, but you all are accelerated math students, and so you will write it in order from least to greatest, okay? Because that's what your teachers in the future are going to expect from you, okay? So the domain, that's the list of all the input values. The range, the list of all the output values. So they give you a set of ordered pairs here, 0, 2, 1, 4, 2, 5, 3, 8. Write it as a table, okay? That's not very challenging, okay? They wrote it out here. Label them X and Y and list the values of X, the first numbers in each ordered pair, and the Y values, the second numbers in each ordered pair. So each X, Y here is an ordered pair from that set that they gave you. You can also write the table vertically like this if you want to. Okay, it's really more common. Even depends on what kind of, I don't know. It doesn't really depend on anything. Some people like them vertically. Some people like them horizontally. Let me also point out you do not need to use a ruler. Okay, you don't have to even write a table with any lines. You can just list these out in an organized way without any lines in between them. Okay, that's making a table of values. Perfectly fine. Sometimes this is called a T-chart. This table, especially the vertical one, okay, you might hear some teachers or some videos or whatever you're watching call this a T-chart. A T-chart is just listing the X and Y values next to each other like this, okay? And then the second part of the question, what is the domain and the range? So you see how they've written out the domain and the range here. The domain is 0, 1, 2, 3. That's the set of all of the X values or input values. And the range is 2, 4, 5, 8. You do not have to write out the words domain and range. I'll show you here in the got it answer. Okay. So express the relation as a table. So you probably don't even really need to do this. Then determine the domain and range. So as a table, I make sure I label X and Y. Oh, Riley, you forgot to label X and Y. Do as I say. X, Y. Okay. It's just good to put, and when in real world problems, it's even more important. You'll see here. More important that you label what is in each column or each row of your table, okay? Then list out the values that go together, 2 and 4, 0 and 3, 1 and 4, 1 and 1. I didn't use a ruler here. I used my crappy pen, which I can't draw straight lines with. That's perfectly fine. Or if you wanted to, you could do no lines and be like that. And that would also be perfectly fine, okay? So you can do it either way. You can do it by hand like this. You can do it with no lines at all like this. Please don't take a lot of time using a ruler for making a table. It is not worth it. Okay, it's not good use of your time. All right. More important question here, though, is what is the domain and what is the range? Okay, so what is the domain for this problem? That's the list of input values, 0, 1, 2, and 3. Okay, 0, 1, 2, 3, the list of input values. What is the range for this problem? The output values, 2, 4, 5, and 8. Notice they are written in braces, right? These squigglies. If you can't write a nice brace thing, as long as it's a squiggly line and doesn't look like a parenthesis, then you'll be fine. But if you don't write those braces, you don't write the domain and range in set notation, you are going to lose points. All right. Now, graphing, okay? So graphing real-world problems here is a very important topic. You're going to be doing this for the rest of your math career. So we're going to spend a little bit of time here on how real-world graphs are supposed to look. And this is a good place to do it because this is all positive numbers in this particular lesson, and most real-world graphs are all positive numbers. You don't get that many negative numbers in real-world problems, okay? So the example here, a seahorse swims 5 feet per hour. So they ask you to make a table of ordered pairs where X is the hours and Y is the feet. Okay, they give you some numbers to use for feet, so they're giving you required the input values to use. Then they ask you to make a graph. All right. Now, one thing I don't like here, which I haven't fixed yet, is that this should be, okay, this should say up here hours, not just X. I mean, it kind of defines what X is in the words, but it's good if you're going to make a table to label it just like you label a graph, okay? Hours and Y is the feet, okay? Y is feet. It's better to label these things. All right, so then you put your order for that. 1 hour, okay, if it swims 5 feet per hour, in 1 hour it's going to swim 5 feet, 1 times 5. 2 hours, 10 feet, 2 times 5. 4 hours, 20 feet, 2 times 5, okay? So there's your table of values. Make a graph, great. They already have the graph made for you, which is really the hard part. We'll talk about that in a minute. 1, 5. Notice the lines here aren't all worth 1, right? They've labeled with numbers on both scales here what each line is worth. 1, 5, 2, 10, 4, 20, okay? Describe the graph. That description would be the points are in a straight line, okay? That's a straight line. I would prefer that the book use the word straight, because later on in your math career, line will not necessarily mean straight in some applications. It's not really true, I guess. Actually, line always means straight. Never mind. Straight line, though. Okay, not a curved line. All right, so we need to talk more about graphing and using algebra in real-world problems because we're going to do it all over the place, okay? So in the Got It, I'm going to go through this one slower. And there's also a notes page here. You probably ought to follow along with this page, print it out and follow along. 1 square mile is equal to, we're on page 33. 1 square mile is equal to 640 acres. Make a table of ordered pairs for X to be the square miles and Y be the number of acres in 1, 2, and 3 square miles. Graph the ordered pairs, describe the graph. Same thing as the example, okay? So 1 square mile is 640 acres. That's what we know. And we'll make our table here. Square miles is the X and acres is the Y. 1 square mile is 640 acres. 2 square miles, 1,280 acres. 2 times 640. 3 square miles, 1,920 acres. 1,800 plus 120. Okay. All right. So now make the graph. Now you're starting from scratch, right? They didn't give you a graph here to do. Okay. So you have to make the graph from scratch. And there's some things that are important in making real world graphs. And so that's what we're going to talk about here. The key pieces of creating a real world graph. Real world graphs require all of these things. We will go through each of these things one at a time. All right. So we're going to start with a rule here that every real-world graph must have a title. The book is not good at this. The book leaves the title out a lot and gets a Mr. Yuck, okay? So square miles to acres is what I am labeling this. It doesn't have to be a fancy title, just something to tell you that what this graph is describing, or okay, what you're using it for. Okay, so that's every graph has a title. All right, moving on. Step 2. The independent or input variable goes on the x-axis and the dependent or output variable goes on the y-axis. You have to know which is which. You have to decide. Sometimes it'll tell you in the problem. Okay, other times it sort of like has to do with what you're trying to figure out. Right? In this case, they told you the input was going to be the square miles and the output, the y value, was going to be acres. Input is always x, output is always y. Okay? You need to label the 2 axes on your graph. What are you graphing? What do these coordinates mean along the horizontal axis, the x-axis? These are going to be square miles. And on the y-axis, we are going to plot the acres. Okay, so that's your labeling of the axes. If you do not label the axes with units properly, you will lose points. All right, now, what about the scales? What numbers do I need on each of these? So you have to look at your problem and see what numbers I have to cover. All right. So square miles, they gave me 3 in the table. So, all right. So we'll do, to kind of use most of the graph. I could just do 1, 2, 3, 4, 5 and use only this half of the graph. But since I have the whole thing, we'll go out here to take 2 spaces for every square mile. Okay. And I write in the numbers underneath each line. You don't have to write all of them, but enough so that you can easily graph and read the graph. Okay. So you look at the minimum maximums. Each one of these lines, each one of these spaces on your scale must be worth the same amount from the beginning all the way to the end. So every line, every space here in this graph on the x-axis, every space is worth how many square miles? Each individual space here is how many square miles? Right, 1/2, right? Each line here is half of a square mile because it's 2 lines for every 1 square mile. All right, that one's pretty straightforward. Let's go to the acres because those numbers are big. So in the acres, we need to go from 0. You don't really have to start at 0, but you can in this case, okay? All the way up to 1,920. So as I'm looking at how many lines I have in my graph, I have 10 spaces here. And I go, well, if I try 100, 200, 300, 400, 500, I can only go up to 1,000. So that won't work because I need to go up to 2,000, right? 1,920. So if I use every line as 200, it fits just right. I can get up to 2,000 here. So that's the scale I'm going to use on the y-axis. Each line on the y-axis, okay, each space here is going to be worth 200 acres. I don't have to label every one of them. The first one is good to label so you know what each space is worth from 0 to 200. Okay, and then obviously round numbers so that you can, when you're in between here, you can easily tell what the numbers are that you are plotting or what you're looking at. Okay, again, each space here must be worth the same amount. In this case, each space is worth 200 acres. Okay, you do not have to start at 0 on the y-axis. Okay, if you don't start at 0 and you have like a break here, you put little lightning bolts in here. I don't know, we'll see any of those, but sometime you might. Okay, you don't have to start at 0. Okay, next step, plot the points. Oh, let me just point out one more thing on these intervals. Do not use numbers that are hard to interpolate in between, to estimate in between. Like, you don't use every space is worth 7, for example. Okay, that's not an easy number to use if it was going to be 7, 14, 21, 28, right? I really don't like 3s. Sometimes in the book, they'll go 3, 6, 9. Each space will be worth 3. I hate that. I just don't think you should be having to estimate a third of the way in between for 1 and 2 if each line is worth 3. 2, 5, 10, 25, right? 4 lines is 100. That's not too bad because those numbers are pretty easy. You want them easy to graph, right? Easy to figure out where to put points if you're graphing, and easy to figure out what the coordinates are if you are looking at the points, okay? All right, next, plot the points. So 1, 640, okay? So at 1 mile, 1 square mile, 640 acres. So 600 is right here. Halfway, each one is 200. So halfway through from here to here is 700. So 640 is a little less than a quarter of the way, right? A little less than 1/4 of the way, because it's a little less than half between 600 and 700. Okay, so you have to, and it just has to be close. It doesn't have to be totally accurate, right? You're not really worried about precisely reading the thing. Okay, at 2 miles, 1,280. So almost halfway between 1,200 and 13 and 1,400. Right, halfway between these lines would be 1,300, so it's a little bit less than that. And the last one at 3 miles, I go up to 1,900. That's halfway in between, and 20, so 1/5 of the way from the halfway up. A little more than halfway is fine. Okay, so that's graphing the points. Some numbers are easier to graph than others. Okay, then the next thing, which is really for future lessons, is do you connect these points? Do they extend in both directions? Would you bring this one all the way down to 0? This one I think is pretty obvious. You would go down to 0 because 0 square miles would be 0 acres. So that makes sense. Okay. And an arrow on this end, because you could keep going. There's no limit to how many square miles you could use this graph for. So an arrow on this end. But this stuff is not really that important for right now. Okay. But it does tell you that this graph is a straight line. So that is an important final conclusion when you look at the problem, what they were asking, okay, that your graph should look like this, and the graph is a straight line, would answer the describe the graph, right? The graph is a straight line. That's my describe the graph answer. If you were with me, I'd ask you if there are any questions. So you'll have to send them as you're doing practice.